I'm glad to welcome you to the second part of our conference today. This is our fourth panel. We have another two very interesting debates and very interesting topics still to tackle on with international presence. But for the fourth one, I would like to invite Aneja, my dear colleague from the municipality. I cannot pronounce it, not even after 30 months of project, to be honest. I would say that Ilirska Bistrica. Bistrica I can say because we have a city in Romania which is called Bistrica, which is really lovely. They have very good tsuika over there. You know tsuika? You know palinka? It's very good in Bistrica. So we have a panel where we talk about the safer cycling route toolkit exactly and pilots, but more about this. And I hope you took your coffee. We have from espresso to cappuccino, everything here. I hope that the people back in the offices, online or at home are still watching us and are enjoying as we do over here. So let's continue our SABRINA final conference and enjoy the next 3 hours. Thank you.
Thank you, Raluca. Hello, everyone. I and my colleagues from Croatia, from Moldova, and from Austria, we would like to, as I said, introduce to you a little more in detail Safer Cycling Routes Toolkit, known also as SCRT, and about our pilots. So let's imagine that we have village A and a town B, and we would like to connect village A with town B. And so we have two routes, the green one and the blue one. And on these routes, there are different vehicle flow, then there is a different infrastructure. So let's imagine that this brown rectangle is a separated bicycle lane, and the other infrastructure is VRU infrastructure. And then we have a different cyclist flow and different pedestrian flow. And we must take into account that also accidents can happen. And we have also a different speed limits. And also, we must take into account that we have a limited resources. So, the question is, which of these two routes we will choose? The green one or the blue one? Which route is the safest or will be the safest? Or it's neither the safest. We have in plan also to build here the separated bicycle path, and we have a design for this. And the question is this design good? Can we increase the safety of cyclists with this design? So these are very important questions. And to answer it, we have a solution. In SABRINA, in Work Package 3, we have developed a Safer Cycling Routes Toolkit. And here you can see the first page of SCRT online. And here is one of the pages of instructions how to use this amazing SCRT. And so I would like to invite Andelo Marunica from University of Zagreb, from Faculty of Transport and Traffic Sciences, to introduce to you a little more in detail the Safer Cycling Routes Toolkit. So please, Andelo, the floor is yours.
So earlier today, we did a very quick crash course through the toolkit, and now I will display all the features that you can actually use within this toolkit. Let's talk first about what it essentially is. So this is an interactive online decision-making support tool. It is really available to everybody right now. And the focus here is on proactive cycling safety assessment. So to assess your routes for safety, you do not need any accident data. which is for cyclists very difficult to come by actually. So it is accessible if you follow the URL here, SABRINA .scrt.eu/SCRT, or you can actually scan the QR code. So what is SCRT actually based on? It is based on 3 cycling route assessment methodologies. IRAP, we talked a bit about all 3 before, so I will be very short. IRAP will consider all cycling to vehicle accidents that will have severe consequences or fatalities. CycleRep considers the risk of a cyclist getting into a bicycle accident, and it considers 4 types of accidents. If you can fall, if you're going to get hit by another vehicle, if you're going to hit another cyclist, or if you're going to hit a pedestrian. And there is also an ECS, which is a route assessment for the ECS certification, and it is not strictly a safety methodology. We also reviewed a lot of available research on the impact of infrastructure on cyclist safety, mainly the crash modification factors, and mostly we used available research on Safety Cube project repository and also the crash modification factor clearinghouse. So let's start with demonstrating what our tool can actually do. When you go to the homepage, you will encounter a somewhat different version of this screen because this is a beta, so not everything was filled here regarding the text on the left side. The main parts of the tool are the four icons and text on the right side. And the tool is divided in 2 parts, basically. The first part is the non-expert part of the tool, where anybody can basically, whoever has basic computer knowledge, you can just access it and you can browse some stuff and see some stuff. I will talk a bit more in details about it later. And the second part of the tool is the expert part of the tool, where you will need some trainings, and you can use this part of the tool to assess your routes for safety. Let us go through all of these now. So the first one is a getting started section. And this is a bit of a draft page here, but the real thing is live on the actual tool. You will get the opportunity, the getting started section, to, if you're not attending any trainings, to actually train yourself, basically, to use the tool. The video tutorials that we did are very detailed, the manuals that we have are very detailed, and we collected a number of frequently asked questions regarding the tool that you can also browse, and you can find out some stuff that our stakeholders and project partners already asked about the tool. Okay, let's go back. The second part is the document repository. So within this part, you will have the opportunity to browse all the outputs of the SABRINA project. They are not updated in their final PDF forms yet because some of them are still drafts, but what you can actually find is the documents that you have all been searching through in front of this lobby. Some other greatest hits like the Danube bicycle route star rating results, and so on. This about covers the non-expert part of the tool. The assessment modules is something that you will use when you actually assess your routes, and there is 5 of these. So the first one, I will cover them in the order which you should also use them when you actually try to assess your routes. So the first one is a cycling cross sections. And here, if you saw the SABRINA Experience booth over there, you can actually select some of the infrastructure types which are being assessed by CycleRep and IRAP methodologies. It's 8 of them. You can also define some of your custom cross sections. You can select the flows that are going to be happening on the infrastructure type that you selected. So pedestrian flows, ADT, which is the average annual daily traffic on the road, and cycling flows. You also select the speed ranges and you click apply, you get the results. The basic results that you should focus on are, of course, the IRAP star rating and the CycloRep risk scores, but there is some other things that you can actually browse through this. So you can also browse the costs, you can browse the reduction potential or the crash modification factor that was used for a certain infrastructure, the safety scores, which is a sum of all accident scores from IRAP and CycloRep methodologies. So regarding this number, the less the number, the safer the infrastructure. So for example, for this infrastructure here, we have a safety score of 11. That's safe, I would say. You can also see what you actually coded regarding the pedestrian flows, cycling flows, and so on. What is important here is that when you browse these cross-sections, this is actually the repository of all available cross-sections that the toolkit uses when you are applying them on your routes. When you create your own here, you are the only one that can actually see it, and it will have a custom prefix regarding this. You can edit a lot of parameters. For example, if you do not like the cost for this segregated bicycle path, you can edit it. If you do not like the reduction potential of it, you can also edit it. If in your country it is not renewed every 20 years, you can also edit that. And this will all be accounted for or calculated rather in other modules of the SCRT. That's it regarding the cycling cross sections module. Let us move on to the other module that's really important and kind of mandatory if you want to assess your routes, which is the GIS module. And within the GIS module, you need to do 3 basic things. First, you need to actually draw the route. So you need to make the layout of your route, as you can see in the video. Then you need to split the route every time significant infrastructure or flow changes. So for this example route, I have split it 3 times from the data I had available. No infrastructure change, but some flows did change. And you can also add ECS attributes on the route. You can see me adding, I believe this was a survey point attraction attribute. Wanted to add some cultural heritages, for example, so we can see how it is being assessed later on. This part is optional though, so if you're familiar with the ECS, you can use it and you can get some results on the presence of these attributes on your route later on. This is basically the GIS module. After you select the route that you did, you, same as within the cycling cross sections, you just add the flows, the infrastructure, and so on. I'm not clicking at it in the demonstration video, but if you click on the eye icon over here, you will actually get the image and what has actually been coded within the individual cross-section. You can click apply and save route, which I didn't do here, because if you click view, you can only very quickly get the results. So what can we see here? You can see the cost, which is the approximation of the currently coded infrastructure on this road. You can see the average IRAP score estimation for the route. On the route that I defined, you can see that this route has scored 4 stars on 9 kilometers, 0.9 kilometers, and you can also see that it scored the same percentage on the other 0.9 kilometers. After that, you can go to the CycloRep score average and see that the medium risk is present on 72% of the route, and you can also see that the low risk is present on 28% of your route. You can see some other statistics that you entered during your layout infrastructure defining phase. So you can see for your route where the vehicle flow is present and in what percentages. You can also see any ECS attributes that you coded here. They will just be added dynamically. And you can also see what cross sections have been added in what percentages of the route here. This is basically the results of the route rating module. You can also compare any of the routes that you save within the module, but just because I don't think there is enough time, I skip that part. So if you're interested about that, you can find me at the SABRINA booth later. Okay, let's go to the other module, which is the countermeasure module. And within this module, the only thing that you need to input on the route that you previously saved is the acceptable price or the investment price. You just need to divide it per 100 meter of your route, and the module will give you a very simple results table of what can you actually build on these cross sections while taking in regards this price. And you can see that for my route there are multiple alternatives here. For the first cross section, which was attributed as a no vulnerable road user infrastructure at all, the module has suggested that I build a shared roadway or a sharrow for 4,000 euros or almost 5, a wide rolled shoulder for this amount, dedicated bicycle lane on a roadway for this amount, and also my custom cross sections that I defined were taken into account. And you can also see that only the first two cross sections were suggested, because the third one was actually coded as a segregated bicycle path, so the module for this price did not find any viable upgrades. Next module is the Safer Cycling Infrastructure Investment Plans, or SCIP as we call it. So this module will enable you to calculate any safety benefit costs for your route, so you can actually plan for your investment. And this is how the input looks like within the module. Here you will select a route, then you will have your cross sections listed in order. Then you can select any viable upgrade that you wish. You will never be able to select something that is a safety downgrade. That's something to keep in mind here. And then after this, you need to define some advanced economical and accident parameters. And the interface looks like this. The first row is reported deaths of cyclists on your route. So, for example, I entered one here for the period of 2010 and 2022. So, within 12 years, we had one cycling death on the route. The fatality and the reporting factor is also something that you need to enter. So, if this number is 1.1, that means that 10% of the accidents are not being reported to the database that I'm actually looking for. You can also define the analysis period of the benefit to cost ratio analysis, and something that IRAP does is 20 years, so this is a number that we would also recommend that you use. Then you can also add a discount rate. This depends on the countries, on the investment banks that are financing you, and so on. For example, here I have placed 12. You also need to define the GDP per capita of the nation where you are assessing the route, and this needs to be in current prices in euros. You also need to define the value of life multiplier in order to get the benefits, and the value of life multiplier that IRAP recommends is from 60 to 100, I believe, and most often the value that is used is 70. Then you need to enter the value of serious injury. So if the value of serious injury is 25% in relation to the fatal injury, you will enter 0.25%, for example. And the final thing that you need to input before you get some cost-to-benefit ratios, you need to input serious injury to fatality ratio. This is how often serious injuries occur in a relation with a fatal accident. So I have put the number 3 here. So this means that for every reported death, 3 serious injuries will happen, quite a high number. And this is how the results will then look like. When you enter these parameters, you can see that in 20 years, for my humble route, 11 fatal and serious injuries are going to happen. The number is quite high because I actually did enter a high number of fatal to serious injury ratio. Here you can see the benefits for the route. You can see the estimated cost of construction. You can see the cost per each fatal and serious injury that is predicted to be saved. You can see the program benefit to cost ratio, and here you can see the network length. The table below shows this only by each cross section that is being assessed within the module. So quite handy. And let's move on to the last part of the tool, which is a conversion tool, IRAP to ECS conversion tool, to be more precise. So what this tool actually does, this is an advanced module of our toolkit, and it is intended for trained ECS or IRAP inspectors. And you use this tool to convert selected attributes between IRAP and ECS methodologies. So when you are assessing both, you actually use this tool to avoid some data duplication. So you do not need to check for ADTs and some other stuff 2 times. It will just be entered automatically for you within the tool. And this is what our tool is all about. So concludes my presentation. Of course, we can go into much more details. So if you have any questions, you can find me at the SABRINA booth, or if you are online, you can use my email, my telephone number, or you can scan this code to get my LinkedIn, and then you can ask me questions there. That's it. Thank you.
Thank you very much, Andelo, for your presentation. The FPZ team is putting a lot of effort in this SCRT. But the question is this tool actually useful? How is it in practice? Because we know that the theory is one thing, but in practice, different occasions can appear. So we are testing it on 3 types of pilots. So they are missing link planning in Croatia, Moldova, Czech Republic, and in Slovenia. Then safer cycling infrastructure investment plan in Romania and in Bulgaria. And then finally, star rating of design. We are testing it in Austria, in Slovakia, and in Hungary. And I would like now to invite Leonid Ljubotina, then Virginia Mandalac, and finally Klaus Machata to introduce their pilots. So, Leonid, the floor is yours.
Thank you, Aneja, for this introduction. So, my name is Leonid, and I'll now show you what we have done. So far you probably know all about the methodologies, all about the tool, and now let's see an example of the actual use. Our pilot was the missing link planning, and we did it actually in conjunction with our local Eurovelo coordinator. So we had some discussion with Ilirska Bistrica, where Aneja is from. They proposed the section between Matulji and Divača. We also contacted our Eurovelo coordinator. He said that every 2 years the routes are being redrawn. So one of the options was also to connect Matulji and Divača in order not to force cyclists to do the entire trip around the Austrian peninsula and take the Eurovelo 8 route. So basically this is the route layout. It's a state road which is right in parallel to a motorway. It's about 17 kilometers in length. The data collection process was quite straightforward, so we contacted the Ministry of Interior for the accident database. There were no cycling-related fatalities reported, fortunately. We also collected traffic flows and speed data. Croatian roads make a publication every year where they summarize the ADT data. And fortunately, we had a previous project on the D8 road from where we could also gather the ADT data. For land use, we used satellite image analysis, and then we identified which parts are rural and which are in the settlement. Here you can see the current situation of the road. So the average ADT for the road is 7,293. The average peak pedestrian flow is 82 pedestrians per hour in settlements, and the average peak cyclist flow is 25 per hour as well along the route. Land use is mostly in the undeveloped areas because there are only, I think, 2 settlements from Matulji up to the border, and the rest is then residential. So, how we did it? We had to draw the route, and this could be a meticulous task if you wish to do it so, but you can also be quite rough to do a faster analysis. So, you draw the line across the road, and then you split the route every time some of the parameters change, like the speed, the ADT, the land use, or anything else. After that, you have to go to the cross-section module, and on the splitted sections, you have to assign the closest cross-section that resembles your current on-site situation. For that, you can use Street View, you can do video recordings, and then you do it for all the sections. After that, you proceed to the coding. You assign the low, medium, and high values to every cross-section, and after that, you can get, of course, the result of the current situation. As the current layout, it has mostly, and unfortunately, a two-star rating, with a smaller section being 1 star, and according to the cycle rep, it's rated as extreme risk across the entire road section. The vehicle flow here is high on 93% of the segments, and it's low on 7% of the segments. What can we do now? So we can of course set an amount that is acceptable to us, according to which we want to promote some countermeasures. And then the tool can calculate, based on the current situation, what could be an improvement measure. Here, for every section, the tool proposed around 4 countermeasures that could increase the safety, and for that you have to pick one that could suit your needs. After that, when we pick them, so here is the final result for our 15 sections. Mostly we selected to add a dedicated cycling lane or a shared roadway. Those were the 2 countermeasures that suit us the most. The total investment for that route would be 173,000 euros, and in total it would propose an upgrade of only, unfortunately, 7%. Because the road layout is quite tricky to tackle with the proposed countermeasures and the proposed budget, the alternative routes should also be considered, where speeds are and vehicle flows are lower, or we can, of course, expand the investment range to enable the inclusion of road safety barriers. And that would be all for the Croatian pilot. Thank you very much.
And the next presentation is about pilot in Moldova. So, Virginia, the floor is yours.
Thank you, Aneja. Hello, everyone. My name is Virginia Mandalac, and I'm representing the Automobile Club of Moldova. I'll speak about what we have done in Moldova with the missing link. As I said previously, Moldova is an entire missing link because we have no cycling in Moldova. So we have it, but it's a hobby, and you can cycle wherever you want, but not on a cycle path that do not exist. We do not have Eurovelo, and we were the right case for the missing link. So the identified section of the road as a missing link was the Moldovan Road R34.1. This section is situated very close to the Romanian border. And it's a Republican road that connects the capital with residence cities, municipalities, and other objectives of national importance. Being of 5 kilometers long, it's a two-way carriage and 3 meters with 3 meters each lane. The road is connecting the city of Cahul with the Oancea locality. So it's the Oancea custom point at the border with Romania and the European Union. This section was considered appropriate and selected for analysis because it has a potential connection with the Eurovelo 6 that crosses Galați, if I don't... Yes, Galați. The conducted analysis showed that no adequate cycling infrastructure is recorded on that portion of the road. No cycling statistical data were available, and no other related information regarding the number of accidents or cycling flow for the selected missing link. The AADT was approximated to 900 cars due to the recordings of the National Border Police, because there are no other means of measurement were available in the field, because it's a field, it's a road crossing in a field. So. The average peak pedestrian flow is 4 per hour, and average peak cyclist flow is 2 per hour. The speed was set for this part of the road. It's like for the most part is 90 kilometers per hour. We have a portion with 30 kilometers per hour, and we have 50, and a portion with 5 kilometers per hour. It's in the area where the customs are. What we did after this, after analyzing the data, we drew the route using the manual, the instruction manual, and here I want to say a big thank you to the developers, because it is indeed very easy and accessible, and even a beginner, so I'm not an engineer at all, I'm a beginner, I just read it and did this analysis. We draw this route, and as you can see, this side-by-side view mode is very useful, as you can see the geography, and it's easier to design, to draw, even if you haven't seen this road at all, never. After this, we split the route in 3 cross sections. Why 3? Because the differences in speed limits for that part of the road. And we introduced for each cross sections, we introduced the features. The features are the same for the all cross sections, so we have no vulnerable road users infrastructure at all. We have only fluctuations, like I've mentioned, in speed, and we introduced like you see, low, medium, the main characteristics, and we obtained the results. So the route rating result showed us that we have 0 investments in infrastructure, as we have nothing there. The IRAP score showed that 81% of the route is rated with 1 star, and we have 14% of the route rated with 5 stars. The cycle rep characterizes, or how to say, rates like extreme risk. The 85% of it's too small numbers. The 85% of the route, but the safety score is like 85, and that's a high risk, because the lower the number is, the lower the risk is. After this, we introduced the acceptable price for 100 meters in the route assessment in countermeasure module. We used the number of 18,993 euros, and therefore the SCRT generated viable options for interventions that fall in this category of price range. There were generated 2 options. of countermeasures with for each cross section with different costs. For each of the interventions, there was presented a total cost for each of the cross section, as well as the difference in the safety score that can be achieved in case of implementation. Consequently, it was observed that a significant difference in the safety score for the Sharrow solution from 43 to 41, so and 12.5 to 12.3 for the second section, and for the third cross section is like from 108 to 103, so it's very insignificant. We can see a better score for the high investment proposed improvements. Taking into account that this toolkit generated for us two type of countermeasures, we made two comparisons. So one with the lower price and to the Sharrow. And this comparison showed us a very significant difference of the safety score from 85 to 80. And the 82% of the route remained rated with 1 star for safety and 40% of the section with 5 stars, so we had no changes. According to CycleRep, 86% of the route remained with extreme risk and 14% with medium risk, with same no changes. That means that as I understand, that the proposed interventions that potential improvement for this part of the road will have no major impact on the actual state of the missing link. Afterwards, in the same module, we compared with the second option. It's a high-cost option, and it is a dedicated bicycle lane on the roadway. Here we have a significant improvement from 85%, from the safety score from 85, we fall down to 25. Yes. However, according to IREP, a difference of 77% from 1 star to 2 stars, it's also insignificant, because 2 stars, it doesn't mean that the road is safe for cycling. Regarding the CycleRep, the risk remained extreme for 82% of the route. So in conclusion, the proposed measures and the performed potential simulation showed us that even with low cost or high cost interventions, there will not be positively influence. And this way, a viable measure for creating a safer cycling environment is lowering the speed on that part of the road, or maybe in the best case is to build a segregated bicycle path separated with a barrier, so which is the safest one. In conclusion, I think this toolkit, it offers the opportunity to the stakeholders to simulate the planning and designing the cycling routes by simulating different situations and check whether different characteristics somehow influence the expected results. It's very useful, it provides useful information, it assists in the decision-making process, and also, like I mentioned, it's very accessible and easy to use. Thank you.
So thank you very much, Virginia. And finally, the presentation of Austria. So Klaus, the floor is yours.
I have the honor of inviting you to the Austrian city of Bruck an der Mur, where we did the star rating of designs pilot just recently. Actually, we're still working on it. The town of Bruck an der Mur is, well, an der Mur means that it is located by the Mura River. Actually, this town is located on 2 rivers. It's the Mura and the Mürz River. It's a bit like Belgrade, just a little bit bigger than Belgrade. Bruck is a town of 15,000 population. And it features the Eurovelo 14. Eurovelo 14 goes east-west between Austria and Hungary. And the new design that the town actually ordered from us, from colleagues of us who did the engineering part, it partly reshapes the Eurovelo layout. Actually, the new design starts at the railway station. This is a major railway hub here and goes right into the town center. The existing layout of this here is, well, no cycling infrastructure. There's just a little, like a 20 meters shared cycling pedestrian path. Otherwise, there is no specific cycling facility in the before situation. So what we did was, as Andelo just outlined, to digitize the new route in our GIS module in the software, in the SCRT module. Right, and then we started gathering traffic flow data. So how do you start out getting flow data where there is no database available? The city does not have anything on flows, neither vehicle flows, cycling flows, pedestrian flows. So what we did is go to Google Street View and check for poles where we could fix the cameras. So our colleagues at the Austrian Road Safety Board nowadays do these traffic sensors poles with these little cameras mounted on poles, traffic signs, wherever, for a day or so. And then there's a post-processing, just analyzing the videos and doing the countings of vehicles, of pedestrians, of cyclists. That's what we did. You know, by the way, you see, this is a minor road network, no high traffic flows, nowhere in the city. And I forgot to mention, there is a general 30 kilometer per hour limit, except main roads. Right, so this is close to the railway station. Here's another camera mounted to do the sensors. Right, and then we went directly into the comparison module to compare the ad hoc, the current situation with the design plans which only exist on paper. I'm coming to that in a second. So we went to this comparison module. And before we entered all these data, traffic counts and, you know, GDP, everything that Andelo just mentioned that you need for the system to work properly. Right. In the before situation, as I just mentioned, there is just a 20 meters shared use path, but otherwise there is only no vulnerable road users infrastructure. And all these values, nearly all these values of flows and speed levels are low. Just to mention that because I'm coming back to that at the end of the presentation. This has some substantial impact on the results of this pilot. So 3 different sections in the before situation, and this is the part of the afterwards. This is the design we received from our colleagues. Railway station is here, so we move cycling from the roadway to a wide pedestrian path. So now there is a shared pedestrian path here, a shared cycle pedestrian path here. We move along here, here across the river, the bridge along the river, shared path again. Then a shared crossing. And no cycling infrastructure here. We move to the next design. No vulnerable road users design here, but here we have a cycle lane contraflow in a one-way, so that's completely new. Then again, no cycling infrastructure, and that's a cycle street. So that's where only cyclists are allowed and some cars, you know, residents predominantly at low speeds. That makes 6 sections now. I don't repeat everything coming from the railway station, ending up somewhere here in the center of town. Right, and for the comparison between the two, I don't even try to explain these little figures to you. The interesting thing is that there is no big difference between the current situation and the situation in the design because of the low speeds and the low traffic flows. So this may be one of the central messages of that tool, of the evidence provided by this tool. And that evidence is you can do new cycling infrastructure, which certainly costs you some money and brings definitely some comfort, some additional comfort to cyclists. But if you don't have the money, and if you have the option of lowering the speed limits and provide a low speed level, you will end up at similar ratings when it comes to safety. Okay, that finalizes my presentation. Thanks a lot.